Hello, my name is k.Haines and I am the Principal Supervisor of this project on the carbon, water and heat fluxes over the land surface. Now we've been able to monitor heat fluxes going out through the top of the atmosphere out to space quite well, and also the surface flux exchanges between the atmosphere and the land surface and the ocean surface for heat and water since about 2000, when we've had very good satellite measurements of these quantities. Now, if we can measure those quantities accurately, the exchanges with the land surface and the ocean surface, we can then get an idea or effectively a direct measurement of the horizontal transports of these properties around the Earth system. And this is something that climate models don't do particularly well. They tend to disagree in terms of the global transports of heat and water around the Earth's system. So this is something that we need better observational constraints upon. Now, a very nice study by a NASA team has developed new estimates of the water and energy cycling in the Earth system directly from satellite observations in a study published a couple of years ago. And in Reading, we've improved upon that study by putting some new constraints over the ocean surface. So we've got better transports around over the oceans. Now, what this project is aiming at is trying to similarly do some improvements over the land surface. Now, over the land surface, there are new data sets that we can bring in to do this, particularly measurements of land surface temperature and how they change through the seasonal cycle. But also, we want to look at fluxes of carbon dioxide and how they're exchanged between the atmosphere and the land surface. Because carbon cycling in the Earth system is something quite new, and we really need to understand it better because, of course, carbon dioxide is at the root cause of climate change that we have on Earth. It's the amount of CO2 that remains in the atmosphere. So what we want to do is we want to use new measurements of carbon dioxide fluxes based on satellite data. These exchanges are based, really depend upon the way vegetation behaves at the land surface. So plant growth involving photosynthesis is taking up carbon dioxide from the atmosphere, and then respiration, as energy is used up by the vegetation, puts CO2 back into the atmosphere. Now, those two processes depend differently on the temperature and the amount of water available to the plant to work with. And those are things that we're measuring separately from satellite measurements. And so we've got this ability to try to couple the fluxes of carbon and the fluxes of heat and water together into a unified system and get better estimates through that process. So that's really an exciting new possibility that we want to try to do. Now, this project, it will be supervised by myself mainly, but we also have, there's a co-supervisor who's particularly an expert on carbon fluxes, Tristan Quaife here in Reading. And we also have another supervisor at the UK Met Office, that's Debbie Hemming, and she's very much looking at how to model carbon fluxes and how they're processed in the Earth system models that the Met Office developed for climate change purposes. So this will really, if we can make progress here, we can really take those results across and provide them as new constraints for climate models so that we can model the way that CO2 changes will occur as climate continues to change. We've got a couple of nice training courses lined up. There's a nice course that's run by the FluxNet community, which look at fluxes of carbon from in situ measurements around the globe. And then we also have another course lined up with the European Space Agency, who run courses on how to use Earth observation data more effectively and what we can learn from that. So if you're interested in this project, please do, if you have any questions, do get in contact with me. Please apply, and if you do so and are interested in this project, you can come for an interview in February next year, when we'll be looking at trying to allocate some of our PhDs to new studentships. Thank you very much.